Yes, sir.
I hope my slide also visible from your end.
Yes, sir.
Okay, very good. So we are discussing about tractive effort. Okay, so where we are going to basically why it is important. So when we are solving the numerical problem, so there are different patterns of numerical problems in traction. Number one pattern is that so you are some numerical problem may be given that data will be given based on the speed torque at sorry speed time characteristics of your different traction systems like mainline service, suburban, urban systems. Okay, so this is one pattern of the exam, one pattern of our numericals. Another pattern is that where you are going to where we are being more thrust on giving that train movement means tractive effort. Okay, tractive effort means what? Suppose the EMU is standing over here, means over a line. Okay, if you want to start the traction motor, what you are doing, you are giving the power to the traction motor, and traction motor is trying to start moving. Okay, but if you can understand there is a huge inertia. Okay, suppose for passenger traction motor system or good carriers, okay, whatever system you have, there is a huge inertia. So what you need to do, you have to overcome that one. Okay, you have to overcome the inertia. So how do you overcome the inertia? So that process is normally known as the tractive effort. Okay, so what kind of effort you have to provide, okay, from your to your traction system, from your traction machines, okay, or traction motor. So that is known as the tractive effort. Okay, so tractive effort having different patterns. Pattern means suppose chain is you can understand, you can realize the problem. Suppose you are having the traction motor and your rail line is like inclined. Okay, inclined up. Okay, so what happened? Your locomotive, you are giving the traction motor that driving towards hilly area. Okay, so inclined up, that is one options. First option is that in the normal path, means normal plain land. Okay, the railway tracks are lying on the plain land and now your traction motors are going. Okay, then one is there inclined up. Okay, another one is that inclined down. Okay, suppose free running conditions. Okay, so in that case you have to provide the sander. So huge inertia is there. Okay, so potential inertia, kinetic inertia. So initially you have to work on that potential inertia. Okay, when it is starting, then you have to work on that kinetic inertia. So both kind of inertias are there. So in that case, you have to provide the sander. Okay, sander means that braking are already there. Okay, the sander means there is a continuous system on relays there. Okay, in that case, continuously sanding that in your track. So providing you additional friction force. So in this segment, we are going to discuss some mathematical equations and the formulas to solving that to solving the problem based on your tractive effort. Okay, this is important and interesting topic. So define different patterns of numericals are there in your home. You can also do such type of numerical problems. Okay, so this portion I have already discussed in my last class. So there is a transmissions. Okay, it's transmissions for the tractive effort. Okay, so you can understand the pinion. Okay, pinion. This is your pinion and this is your gear. Okay, pinion gear coupling. Here you can see. Okay, so D is what? D is that road wheel. Okay, diameter of the road wheel. Road wheel means pinion is already there. So directly pinion is not connected to the wheel. Okay, pinion is connected in the wheel is the pair of wheel is coupling. Okay, pair of wheel is connecting through the shaft. Okay, so one shaft is there. On inside of the shaft you can see some tooth gear is there. Okay, some toothing of gear is there. Okay, now pinion is connected with the gear and that you are providing that traction's motor shaft is directly again through that gear, okay, through the shaft of that motor is directly coupling with the pinion. Okay, that here you can see it is called the pinion. Okay, small, that one is known as the pinion. Okay, directly coupled with that one. Okay, and that pinion is connected with the through the gear with your wheel. Okay, two wheels are connecting through the shaft. Okay, now shaft is one gear is there inside of the shaft. Now that pinion is responsible for movement of the shaft. Okay, so you know that transmission in drives, you know that how to transmit that linear movement to the rotational movements. Okay, so in drive it was there, suppose pulley is there. Okay, so some arrangements are there. So based on that formulas, that plus 2 level formulas you are using. Okay, plus 2 level formulas, two force are there, how to calculate the torque, everything. Okay, so what is there? T is torque exerted by the motor. Okay, armature traction, this is armature traction motor. Okay, so the directly connected with the pinion, this is your pinion of motor. Okay, so traction motor, the pinion of the, so internal diameter is there, d dash, and here you can see the diameter, small d is there. Small d means diameter of the gear wheel. Okay, so wheel gear means one gear is there inside of that shaft of the wheel, two wheels are connected. D dash is the pinion. Okay, that I am telling about you, the pinion. D dash is the pinion, and capital D is the diameter of the road wheel. So capital D is the diameter of the road wheel, that two wheels are there. Then gamma is the gear ratio, d by d dash. D is your diameter of your gear wheel and d dash is your pinion wheel. Okay, diameter of the pinion. So you can find out the efficiency. The driving motor exerted torque T in the Newton meter. F dash is our tractive effort at the pinion. Capital F is the tractive effort at wheel. Okay. Let driving motor exerted the torque capital T in Newton meter, tractive effort at edge of pinion in given by T equal to capital T equal to F dash D dash by 2 or F dash equal to 2T by D dash. Okay, that is the total force. Okay, the tractive effort transfer the driving wheel, that F equal to N F dash small d by capital D. That's basic formula directly coming. Okay, so from that you know the transmission. Finally, you can find out the total you can find out the total tractive effort from the wheel, that directly using that formula. Okay, if you have all those things, directly you get that force value. Okay. Now coefficient of addition. Okay, so coefficient of additions means what happens. So if you want to movement of your wheel, okay, from the rail, but initially what happened, it's not try to move. Okay, that portions I have already discussed. Still I am going to rediscuss some of the portions. Okay, maximum friction force. Okay, so problem is the maximum friction force is there. Okay, so between your wheel and track, that is mu into W, and your force, total force should be less than your mu into W. So at that condition, without slipping, okay, so motions of the train without slipping means if that force is greater than mu W, so it will be slipping. Okay, mu W means you know that basic formula of the friction. Okay, and coefficient of addition, that mu is known as the friction type. Okay, tractive effort to slip the wheel and adhesive weight. Adhesive weight means that EMU weight. So mu values are given. Okay, with the different speed, mu value is gradually decreasing. Okay, with increasing of the speed in kilometer per hour. Okay, for clean and dry rail, okay, mu value is 0.25. Okay, for wet and greasy rail, that is 0.08. Okay, so depends upon which conditions, friction between wheel and rail, series parallel connections of motor, speed restoration, drive, smoothness of which of the torque can be controlled, nature of the motor, torque speed characteristics. So different processes are there, so it will be based on that. Now the most important portions, that propulsion, tractive effort for propulsion. First one, that coefficient of addition means that how much friction you need to overcome at the time of starting. Then what happened? Your relay, your EMU wheels are start propulsing. Okay. Now what you need to do? You have to calculate. So what are the effect? Okay, traction effect of the accelerations. Okay. Different conditions are there. First one, the tractive effort for acceleration. So if you want to increase the speed of the train. Second one is the tractive effort of overcoming the effect of gravity that I am telling about. So center is required. So now it is inclined down. Okay, your railway now EMFs are inclined down. So in that case, you can consider that is your wheel. Okay, it is your wheel of the traction motor. Okay, so the total W is there. W into mu is normal one, but in that case, W mu cos alpha is there. Okay. So G is your gradient. So force due to the gradient Fg equal to 1000 W sine theta. That sine theta is that angle of incline. Effect of the gravity, how it is running down. Okay. Percentage of gravity is there, G percentage. Okay. In previous case, another one is there, tractive effort overcome the train resistance. Okay. So three conditions are there. Okay, so three conditions are there. First condition is that tractive effort for acceleration. Okay, so when train is going to start, so in that case you are talking about the propulsion, the effect of the force necessary to propel. Okay, to propel the train at wheel of the locomotive called the tractive effort. Okay. Now, what are the most important features are there related to the tractive effort? So that required to run that run train on the track. What are the important features? The tractive effort required for linear and angular acceleration. What kind of acceleration? Linear accelerations for the train and angular acceleration for your wheel. Okay. Plus tractive effort to overcome the effect of gravity. Okay. So that friction is the static friction, so that totally solely depends on your gravity. So you have to overcome the gravity also. And last and final one, plus the tractive effort to overcome the train resistance. Okay. So first condition you can see tractive effort required for the linear and angular accelerations. Okay. So total tractive effort depends upon your three factors. First factor is that accelerations, linear and angular acceleration. Second factor is that overcome with the effect of gravity. Okay. So that one gravity. And third one is the tractive effort to overcome the train resistance, means friction. One condition is that static portions, okay, that is your overcome with the train resistance. Second condition is that it is valid for friction as well as that effort to overcome of the gravity. You have to overcome at the time of when train is in standstill condition, that is another condition, and when train is running conditions, at that condition also gravity is there. And final and full and final most important thing is that how do you accelerate your train? How do you accelerate your locomotive? Okay, so linear and angular acceleration. So Ft, tractive effort, equal to Fa plus minus Fg plus Fi. Why plus minus? There is a two condition, inclined up either or inclined down. That's why plus minus Fg is there. Okay. So first one is that acceleration Fa. Okay, how they are directly related to the tractive effort Ft. Okay, force equal to, you know, that mass into acceleration. Okay, m into a, m into alpha. So you know that m should be in ton in case of locomotive. You can convert in the kg. Okay, so 1000. Okay, 1000 w ton the weight of chain. Okay, so 1 ton equal to 1000 kg. So 1000 w kg. Acceleration, you know that alpha, that is given in kilometer per hour per second. Hour means 3600 second. Okay, so that's right. And kilometer means you can convert it meter per second. No? Means 5 by 18 normally we know. Okay, so 1000 by 3600. That is meter per second square. So it's coming 0.2778 alpha. Okay, so now force F equal to m, that m equal to 1000 W. Okay, it is in kg. Okay, and meter per second square. Kg meter per second square means Newton. Okay, N. So you know that F equal to m into a, you replace those things. m into alpha 1000 w into 0.2778 alpha, directly it is coming F equal to 277.8 w into alpha Newton. Okay, I hope all of you getting this one. Okay. Rotating part of the train such as the wheel, okay, and the motor also accelerate in the angular direction, that I am talking about. So angular acceleration will be considered for your wheel rotation and motor shaft rotations. Okay, accelerations. Tractive effort is required for the equal to tractive effort required for having the angular acceleration of rotating part, and tractive effort required to have the linear acceleration. So these all are the required portions. Okay, so due to that angular changes, you are getting that finally linear movement. Okay. Then angular acceleration depends on the individual weight and the radius of the gyrations. Okay, means gravity dependence. Okay, sensor. Okay, gyrations rotating of the part of the train. So how much W equal to equivalent or acceleration weight of train. So due to you are giving some constant value. Okay, that is equivalent or the acceleration weight for the train that's required. Okay, WE greater than W. Okay, so 8 to 15%. It is coming 8 to 15% overall. The tractive effort required for the acceleration F equal to 277.8 W E alpha. Okay, W suffix E into alpha. That total value. Okay, so angular acceleration you are considering. So finally you will get WE. Okay, that is 8 to 15% of your W more. Okay. Now you are considering that overcoming the gravity that I am talking about. Normally W into mu is there, but if the angular movement is there when train is on slope, okay, tractive effort with the gravity when train is on slope, a force of gravity equal to component of the dead weight. Okay, so force component means W cos alpha. The W is there, okay, but when dead weight is there, so that W cos alpha, that value, okay, along the slope act on the train, and train tends to cause its motion down the gradient of the slope. Okay, that's my cause for the gradient of the slope. Force due to gradient Fg equal to 1000 W sine theta kg. Percentage of gradient is percentage G percentage, that is G sine that force. Okay, that is G equal to sine theta, and coming that percentage of G equal to coming 100 into sine theta. Okay, sine theta how much value is there? Okay, so you can replace that one. G by 100%. Okay, G percent over divided by 100. So if G equal to how much value? 10. Okay, 10 W G percent. Okay, now we are multiplying. So finally we will get Fg equal to coming 98.1 W G percent in Newton. Okay, I think you are able to understand. Simple thing, nothing complicated. Okay. And finally, the tractive effort to overcome the train resistance. Okay, so you have the tractive effort to overcome the train resistance. What are that formula? The train resistance consists of all the forces, okay, all the forces resisting the motions of the train when it is running at uniform speed on a straight and the level track. Okay, so overcome the train resistance means when it is in straight conditions. Okay, running in that constant speed, you have to overcome that train on. So train resistance, what are the important factors? Okay, of the train resistance, the frictions at the various part of the rolling stock. Okay, the friction between track and wheel, air resistance. Okay, so these three are the main important thing. Okay, for the rolling conditions, frictions for the rolling conditions, friction between the track and wheel, and air resistance. Okay, sweep conditions. Okay, total resistance R equal to K1, that is first constant. Okay, second one K2 V. Okay, that directly proportional to the constant depends upon the train type. Another one is K3 V square. Okay, V is the speed of the motor. Okay, speed of the motor in kilometer per hour, and R is the resistance in Newton. Okay, directly. That's the formula. You can consider for that one. Okay, friction between the track and wheel, that is K2 into V, and air resistance. You know that for the air resistance, that normally considered such a CV square. Okay, so that component for the air frictions. Okay, and K1, K2, K3 are the constant and depend upon the train and the track for the specific condition. Okay, the tractive effort is required to overcome the train resistance. So you have to overcome the train resistance. So Fr equals to there, Fr equal to W into R. Okay, so Fr equal to W into R within bracket Newton. Okay, where R equal to specific train resistance, N equals to Newton, sorry, ton at the dead weight. Okay, so that's the conditions. So what are the total tractive efforts? So F alpha plus minus Fg plus Fr. Okay, some mistake is there, printing mistake. So it should be plus Fr. Okay, Fg plus Fr. So you know that value F alpha equal to 277.8 We alpha plus minus Fg value is already there here, 98.1 Wg% plus W into R. Here you are getting. Okay, overcome the train resistance. W into capital R. So R value equal to K1. Okay, K1 plus K2V plus K3 V square. Okay, so these all are that value. So positive sign is for motion of the gradient and negative sign is the motion down of the gradient. That means inclined up conditions and inclined down conditions. Okay, so that plus minus given in this manner. Okay, you can specify in this manner. Now we are discussing about the AC electric locomotive. What are the most important features for our normal AC EMU? Okay. So what are the most important features for our EMU conditions? Here you can see from pictorial representation. Okay, for the AC locomotive. Okay, so first one is your overhead conductor. So overhead conductor having two wire. One is called catenary, another one is known as contact wire. Okay, then you can see the pantograph. Okay, pantograph is there. Okay, this is your pantograph. Okay, pantograph is situated rooftop conditions. Then conductor is coming to circuit breaker. Okay, circuit breaker and isolator both are there. Okay, circuit breaker and isolator. Okay, air blast circuit breaker, or you can say like that, vacuum circuit breaker. For suburban and urban condition, you are using vacuum circuit breaker. For mainline service, we are using air blast circuit breaker. Okay, here you can see the circuit breaker. Now that conductor is coming like that way. Okay, from roof you can see that insulators are there that can carry the conductor. Then conductor is coming in the transformer. Okay, inside of the motor coach. Okay, so transformer is there. Transformer having three winding transformer. This is your main winding. Okay, another two windings are there. That is known as auxiliary windings. Okay, so that auxiliary windings are responsible for internal distributions, electrical distribution systems. Okay, fan, light, relay power, then other emergency lamp. Okay, so other necessary thing. Okay, and then main windings is responsible for the movement of the tractions. Okay, here you can see the transformer. Then diode rectifier is there for converting that AC to DC. Okay, and smoothing reactor is there for making that DC, means when you are converting AC to DC, so the nature of the DC is in pulsating in manner. Okay, so who will responsible for making in the proper DC? So the smoothing reactor. Okay, so here you can see the smoothing choke is there. For it's a, you can see there is a coils. Okay, smoothing reactor coils. Okay, smoothing choke. for making them fix up, normally constant DC. That DC directly connected to where, that you can see that two wheels are there, means for individual, for wheel, here you can see it's a pair of wheel, another set of wheel also be there, that is another end that is not visible. Okay, this is second set of wheel, so that setup also be there available in the another wheel. Okay, so only 1D diagram is there, so we can sorry, 2D diagram is there, so we can see only these two wheel from this one. Okay, so two wheel means two motor, two locomotives will be there, two traction motors will be there. Okay, for individual wheel pair, one traction motor. Two wheel pair, you are using two traction motor. One is dedicated for first wheel, another one is totally dedicated for the second wheel. Okay, so at that, after that you can see that these all are the driving wheel. Then you can see the back. Okay, so another two wheels are there. Okay, so that wheels also with the same conditions. Okay, when the both the wheel will be so it can go same direction as well as backward direction. Okay, and that individual wheel pair may connect with the traction. So in the system you can see that four pairs of wheels are there, means four traction drives are there. Okay, so you can easily understand for the number of wheels from your motor coach. Okay, so more number of wheel means uh, more number of wheels may cause for more number of motor, traction motors. Okay, that you can understand. So what are the most important points? Here you can see the railway track or the returning path. Okay, railway tracks. Okay, AC electric locomotives. Okay, important points are there, that overhead conductor. So here you can see that overhead conductor. That conductor value is coming 20 to 25 kilovolt. Okay, so that I told you that that voltage, why we are choosing the voltage. So nobody can steal that. Sorry, nobody cannot hook. Okay, ATC loss is the very common problem in our Indian culture. So hooking, to reducing the hooking problem. Okay, basically that bare conductor throughout the country. Okay, so if it is in common specification, so the manufacturer face some difficulties. That's why some different specifications you are that it's preferred. Okay, so here you can see that pantograph. After that circuit breaker, you can see the pantograph. The pantograph, it is a current, okay, current sending device. Okay, current sending device mounted on the roof of micro locomotive. Okay, so here you can see that pantograph is connected. Okay, mounted on the roof of the locomotive. It collects the required power from the overhead conductor and the feed to the locomotive. So collect the power and from the overhead conductor and feed to the locomotive. Okay, so then what happened? Then circuit breaker is there. So circuit breaker, what happened? The circuit breaker is protective device, locomotive equipments. Okay, so any protections, any signal emergency stopping, so that can remove your system from that overhead power line. Okay, that benefits is there in pantograph. So the collect the required power from overcome so from overhead conductor and the feed to the locomotive. These all are the very common one. Then circuit breaker is there, breaker of the productive the locomotive required, so mounted on the roof of the locomotive. Function of the circuit breaker to make on and off both the normal and the faulty conditions of your wire. Okay, so it can be controlled from your directly, that based on the conditions. Okay, then on-load tap changer, that I am talking about you for the mainline service, whatever you are providing that on-load tap changer. For online tap changer. For offline tap changer, okay, that also been used, but not here. Okay, so on-load tap changer is a speedy regulator. Okay, of the device of the motor. If the regulates, okay, motor speed by the varying voltage from input side of the transformer. That's the basic reason for that tap changer. And transformer is used to step down the line voltage from 25 kV to 100 V at the required voltage to run the traction motor. So that is possible. Okay, and that kinds of important definition you please keep ready for understanding and why they are important. Okay. So these all are the, you can see these all are the electrical features. Okay, now you should think about the mechanical features. Okay, so traction motor, other features is your mechanical features. Okay, so you are using what type of wheel. Okay, so electrical features that here you can see some important points are there. Okay, overhead line, then pantograph. Okay, after that circuit breaker. Then what you talking about, that on-load tap changer, that auto transformer is there for varying the traction voltage. Okay, that mainline winding, that that here the transformer. Na? Then after the transformer, one that winding is the auto transformer. Okay, so directly auto transformer. So you can vary that one. So after that, if you are able to vary them, so automatically the speed can be controlled. Okay, so on-load type changer, another transformer is there. Okay, then what are the important mechanical features? So that mechanical features is the traction motor. Okay, traction motor must be robust and the capable to withstand the continuous vibrations. Okay, so vibration is the preliminary factors. Okay, when you are moving your train. Okay, so vibration will be definitely there. So you cannot avoid the vibration. So what you can do, you define the system or you design the system such a manner there is a robust and capable withstand conditions will be there. Okay, the weight of the traction motor should be very minimum in order to increase the payload. Okay, if the weight of motor is more, so it may cause for additional payload. So in that case, you can follow that in machine designing. You can follow some armature and other, sorry, follow aluminum and other kind of winding. So you have to check that feasibility, is it is working or not. Okay, that's the important thing. The weight, okay, weight is another important concern. Weight more means inertia problem will be there. Okay, then the traction motor is located underneath a motor coach, therefore must be a small and overall dimension is required. Okay, dimension to say the diameter. So how much dimension will be there? So there is some standard guideline. Okay, so based on the guideline, you can design your motor for implemented for the traction system. Okay, the traction motion motor is located under the under the motor motor coil, therefore mass small in the dimension shortly and overall diameter. Okay, so these are the important features. The traction motor must be totally enclosed. Okay, totally enclosed by the particularly when the mounted between the locomotive and the motor coach. Okay, on the motor coach and provided the protections against ingress of dirt, dust, water, mud. From here you can take the protections. Okay, important features what? The magnetic circuit traction motor in cast iron which cannot withstand the continuous vibrations, not sustainable. Okay, so we cannot use that cast iron material. Okay, so there is some problem. The use of the cast iron or fabricated steel which gives the more mechanical strength. Okay, more mechanical strength is made in the place of cast iron. Okay, and those part of the motor which are not highly stressed. Okay, that portions are not so much stressed. Okay, and must be made the pressed and the fabricated steel plates and light alloys. Okay, so these all are the very important constant for the mechanical features. For electrical features, what are the most important points? First one is that high starting torque. Okay, so you are aware about it. Okay, so high starting torque is there. Okay, for initial friction, so motor must be capable to developing high starting torque, especially when train is um, accelerated. Okay, that time is required. Next one is the simple located control. Okay, simple speed control. Okay, so simple speed control, so you can do that auto transformer terminal for armature voltage control. Okay, next one is that field control. You can change the field excitation through that same conductor. It's a series machine. Okay, also with the changing of the plug. Okay, so directly you can with the changing of the polarity directly you can do that. Okay, self-revealing property. Okay, the speed torque characteristics of the motor should be such that the speed may fall with the increase of the load. Okay, speed is increased, suddenly load is there, so it may be tendency to reduce the speed. The motor having such speed torque characteristics are self-protective against excessive overloading as power output of the motor is proportional to the product of the torque into speed. These all are the very common thing. Okay, so directly you know that formulas and you can get it. Okay, the dynamic and regenerative braking. So coasting period, so mainline service, that regenerations will be possible. Otherwise, if you implement the regeneration, so system insulated. Okay, that directly that going to be damaged. Okay, so when you are doing the regeneration, so the speed should be sufficiently good and you have to monitor continuously when you are going to take the regeneration for which speed. Okay, so everything is very important. Okay, capacity of withstanding of voltage fluctuations. The reaction should be capable for withstanding the rapid fluctuations supply voltage without undue effect on its performance. So these all are the very basic one. Okay, capacity for withstanding the temporary interruption of the supply. So that's why you are using battery bank. So continuously it is going to be charged. So suddenly power supply is not there. So we can manage that on. Okay, so that's why you have to power supply is very important topic for it. Okay, so I hope you are able to understand. If then another important thing is that overload capacity. Overload capacity means you can see that load normally defined as the which one is your load, which that means the component drawing the current, that is your load. Okay, overload means over current is uh, continuously fetching by the devices. Okay, so that's the problem. So over voltage is fixed now. Okay, direct current is going, so if that's the situation is arise, so your system may be damaged. Okay, so that's why overload capacity is very important. How much maximum current will be follow through your system, okay, to that machine conductors, that is more important. Okay, when you are fabricating the machine conductors, the size of the machine, then what are the most important features of the machines, okay, maximum speed, what type of braking is possible, that okay. So there are different features are there. So based on the overload, so you have to think about. Okay, so parallel running condition. Suppose one motor may cause for what? That one motor may cause for um, not fulfilling all the functions. Okay, so that's why parallel is required. Suppose one converter is not working properly, so then directly parallel base that converter is there, directly they can involve them directly. Okay, so these all are the very basic idea about our traction. So parallel running means what happens, the more than the one motor, that is called the parallel. 2 or 4 motors per motor car. So in normal EMU motor car having 4 traction motor. Okay, so 4 motor cars, so so they can enter to that one, and if emergency braking is there, so they can resolve that braking. Okay. Require the traction motor, therefore should be such speed torque and the current torque characteristic, that when they are oped, when are they are oped in parallel, and the current torque and the both are operated in parallel and mechanically coupled, they share the load almost equal. Okay, so based on your loads almost equal, so unbalancing chances are less. So these all are the very important things. So no motor meet will the requirement of the mentioned above. Most suitable motor for DC systems are series and compound motor, whereas AC system single series and three phase motor are also employed. Okay, so these all are the very basic patterns. Okay, these all are the very basic considerations for our motor power system. So from next class we will start about starting of speed torque control of DC motors. Okay, and where it was mentioned that how the rheostatic controls are there, series parallel control, how the configurations are work. Okay, then field control and chopper DCM, how is it connected. So it was discussed in my next class. Okay, so some pending portions are there that can be covered by this week. I so it will be completed by this pending portions. Okay, so any doubt from your end? Is there any doubt from your end? Any doubt from your end? Okay, so I hope you do not have any doubt. Okay, so if you have any doubt, please let me know. Please note it down so we can discuss. Okay, that points. Okay, so thank you all of you.
Thank you, sir.
Thank you, sir.
Okay.